in this question, we've effectively been asked, we've been presented with an equation. CH4 plus O2 produces CO2 plus H2O. And what we've been asked to do is effectively balance this equation by putting some numbers in front of it. And it's also been specified that we should only use whole numbers in balancing the equation. So effectively, when we get to our final equation, it should be in all whole numbers, right? So how am I going to approach this? Well, in the context of balancing equations, one of the first things I would do with the starting equation is I'd effectively do an audit. And what I mean by that is that I want to know, what do I have of each atom? Well, what do I have of each element, right? In terms of the atoms of each element present here. And so I'm going to effectively produce a list. So here we've got carbon, hydrogen, and oxygen on the left hand side, right? So if I just put that as left hand side, LHS, right? So we've got carbon, hydrogen, and oxygen, right? So how many carbons do we have on the left hand side? We've got 1. Hydrogens, we've got 4, right? And oxygen, O2, so we've got 2 oxygen. And I'm going to do the same thing now for the right hand side. Okay, so for the right hand side, right? So if we do almost the same thing, right? So CH₄O. So how many carbons do we have here? We have got 1 carbon, right? And hydrogens. So hydrogens, H₂O, right? So that's 2. So we've got 2 hydrogens. And in terms of oxygen, we've got 1 oxygen here, but then we also have 2 from the CO2, right? So that would be 3 oxygens, right? And so as you can see, when we compare now the left hand side and the right hand side, we can see it's not yet balanced. Okay, so we've got okay, the number of carbons at the moment are equal, but the number of hydrogens are not, the number of oxygens are not. So what I'm going to do is I'm going to approach this initially by trying to balance the hydrogens, right? And how I'm going to do that is by putting a 2 in front of the H2O we have here. So if I just write out what the equation would look after I've taken that step, that would effectively be CH4 plus O2 produces CO2 plus 2, right, H2O. Right, and my goal in doing that is to try and make the hydrogens on the right hand side be equal to the hydrogens on the left hand side, right? So we had 4 on the left hand side right at the start. But what you notice is that by doing that, I've also changed the number of oxygens on the right hand side. So what I'm going to do is I'm going to do a quick audit again, and I'm going to check, well, okay, well, what's the current state of the balance between the two, right? So if I do that again, so do left hand side, right? So we didn't actually change anything on the left hand side, so it literally, this is all just going to be the same, right? So it's literally going to be CH₄O, and it's literally just the same numbers as we had before, since we didn't change anything here. So it's literally just going to be the same, 1, 4, 2. But if we pay close attention to the right hand side, which, as we know, we have changed right hand side, so that should be that's an R. So on the right hand side, now the number of carbons has not changed. We didn't put anything in front of the CO2, right? So that's just going to be the same, but it's just going to be 1. But obviously the number of hydrogens and oxygens is both going to change. So hydrogens, we put a 2 in front of H₂O, so that's going to be that's now going to be 4, right? So 2 times the 2, right? And for oxygens, we have oxygens here, and we also have here. So that's 1, 2 plus, because of the 2, it's going to be 3, 4, right? So it's now going to be O4, okay? So if we now look at what we have on the right-hand side compared to the left-hand side, what you can see is that a lot of things are actually now balanced. We've got the carbons are balanced, the hydrogens are balanced, but the oxygens are not, right? And if we look at this equation and we ask ourselves, well, what would be a good way to get the oxygens balanced without creating complications? You can quite clearly see that on the left-hand side, we have O2 on its own, right? And that creates a very seamless opportunity to effectively get the oxygens to be balanced. So what I'm going to do is I'm effectively going to insert a 2 in front of the oxygen, right? And that's to make this into a 4 effectively. So I'm going to write out what the new equation would look like once that measure has been done, right? And so that would be effectively be CH4 plus 2, right? O2, and that then produces CO2 plus 2 H2O, right? And now I'm going to do an audit again. Okay, so left hand side, CHO, wow, that shouldn't be CHO. So as you saw, we didn't actually change anything as far as the CH4 in this kind of cycle. So that's going to be the same. It's going to be 1, right? But the rest are going to be, well, yeah, again, hydrogen, nothing's changed. And for oxygen, we've put a 2 here to make sure it's balanced with the oxygens on the other side. 2 times 2 effectively, so that gives us O4, right? And if we bring our attention now to the right hand side, CHO, in this last cycle, we didn't change anything on the right hand side, right? It's simply the same as what we had earlier on, and we already did our audit of that side. So this would more or less be the same thing. So it'd still be 1, 4, 4, okay? And if we now compare the left hand side with the right hand side, what do we find? Well, what we find is that we've got all of the number of the atoms of each element matches between the left hand side and the right hand side. So because of that, we know that now it's balanced, right? And in effect, because of that, we can effectively, I mean, if we bring our attention back to what it said at the top, ordinarily, and well, you see it specifies whole numbers, right? It specifies whole numbers. I mean, if you were to put a number in front of these, which we wouldn't necessarily need to, but if we did, it would be effectively a 1 here, right? 1, 2, 1, 2, right? But I mean, we wouldn't necessarily need to, in the actual answer, we wouldn't need to put a 1 here. So effectively what that becomes is simply just, as we've got in the bottom, it would be simply CH4 plus 2 O2 plus CO2 plus 2 H2O, right? So the numbers are mainly just for the oxygen and for the H2O, right? And so this would be effectively our final equation, our balanced final equation, CH4 plus 2O2 produces CO2 plus 2H2O. Okay,